Okay, good morning, grade 8s, and thanks for tuning in to watch the answer video. There's still a lot of people who have not submitted their picture of their work prior to receiving the answers. And what I'm hoping to do is that you practice the questions, you try the questions, you do it on one piece of paper, one side of a piece of paper, so you can just take one picture, and then you could send me a copy of that work before you get the answer, so I can just take a look at your work and see how you're doing. And then today, what you would do is you take that sheet and all of your mistakes and any answers that you didn't do, you could then write in the correct solutions to all of those questions and use that sheet as a reference for future reachbacks. So make sure that you take a picture of your work on one page. Make sure it's try and make it on one page if you can. I know some of you have to write pretty small, but it makes my job a lot easier. And then email me the picture of your work. Now, a lot of you are using two different emails. I have a cloud.edu.pe. Just everybody email it to my edu.pe.ca, and you all know the first part of it there. And that way, when I get the email, I'll be able to open it up in one area. And in the subject of your email, please write your full name, first and last names. Um, don't just put Logan. If you have a last name, put your last name as well, because I have multiple Logans that I teach. Okay, here we go. Question number 1. It says, using all three methods, equivalent ratios, unit rate, and cross multiplication, solve this proportion. It says if a train can travel 120 kilometers in 3 hours, how far will it go in 5 hours? Now, the first method here that we call equivalent ratios, and I'll highlight it here, equivalent ratios, is if I was to write down 120 kilometers in 3 hours, that is equivalent to how much in 5 hours? And just like we would do if we were making equivalent fractions, we would say, well, what do I multiply the 3 by to get 5? And what I like to tell people is, well, what if it had been 6? What if it had been 120 over 3 equals something over 6? Well, you would have multiplied 3 by 2 to create the equivalency or the proportion. And what we would have done is we would have taken this number divided by this number would tell me what my multiplier is. So because this number divided by this number told me what my multiplier is, then this number divided by this number will tell me what my multiplier is. Now, the only problem with this question, and the reason why you wouldn't use this method if you had a choice, is because our multiplier, as we're going to see here when I pull up my calculator, if I go 5 divided by 3, it's a repeating decimal. It's 1.6 repeating. So what I'm doing here is I'm multiplying by 1.6 repeating both times. Okay? And the problem with that is when I take my calculator and try and ask it what is 120 multiplied by 1.6 repeating, I have to put this in as far as I can, right? And then I press equals. And it doesn't tell me the answer I'm looking for. What it tells me is 199.9 repeating, but the actual answer is 200, okay? So if this was a question and we were trying to solve it, we would not use equivalent ratios because it ends up being a repeating decimal. And it's not a very useful method for this particular question. The second method is unit rate. And if I take that 120 kilometers in 3 hours, and I determine what the unit rate is, that means in 1 hour, that's our unit rate because our second term is 1. Well, here I know I'm dividing by 3, and up here I'm dividing by 3, and I end up with 40 kilometers in 1 hour. Or, if I wanted to, I could write it like 40 kilometers per 1 hour, right? That's the unit rate. And once we have the unit rate, what that allows us to do is then say, well, if I know how far it goes in 1 hour, then in 5 hours, it would be 200 kilometers, okay? And that's the method you needed to show for the second method, which was called your unit rate. So the first one you had to multiply by 1.6 repeating to get the answer. The second method you needed to show was this work here. And everything I wrote here, if you want to press pause and copy it down, you can. That's the work you needed to show for unit rate. And your third method is the cross multiplication. So if I take my 120 kilometers in 3 hours, and remember we said we could set it up as x over 5 hours, and then we realized that in order to solve this proportion, what we can do is we can multiply across the equal sign to the variable, and we get 3x as one side of our algebraic equation. And if we multiply across the other way, and multiply, I get 120 times 5, which is 600. And when I get this simple algebra question and isolate the variable using opposite operation, I end up with x equals 200. And therefore, he will go 200 kilometers. Right? So this is our cross multiplication. I think we called it cross algebra. Cross algebraic, actually. I don't think we call it cross multiplication. So if you want to use that work, you can press pause, copy that down. You will receive another question like this again. So if you're having difficulty remembering the three methods, just have this sheet as a reference. Put a post-it note or a highlighter or a little red ink or whatever you want to use on the question itself, and remind yourself what mistake you made today, so that next time you get a question, you won't make that mistake. Our second question is Pythagorean relationship, and it asks you to solve two ways, both a diagram and a formula. So with a diagram, what we learned was if we attach squares to all of the sides of a right triangle, and Pythagoras said the area of the two squares attached to the legs, this is a leg and this is a leg because it makes up the 90-degree angle, their two areas added together will be the area of the square attached to the hypotenuse. So if this side length is 8, then the area of this square would be 64 meters squared, or 8 times 8. And if this side length is 16, then 16 times 16 is 256 meters squared. And if I add those two together, and you can do 256 plus 64, you get 0, 11, sorry, 12, because I had to carry my 1, and 3, you get 320. So that means that this square here is 320 meters squared. Now, what did we learn if we know the area of the square is a certain number? We know that the side length will be the square root of 320. So x is equal to the square root of 320. That's what its length is, which is approximately equal to, if we take our calculator here, where's my calculator? Right here. And say, what is the square root of 320? It tells me it's approximately, if I round to one decimal place, 17.9. So therefore your answer is approximately 17.9. Again, if you use the diagram method, that's the expectation for what work you showed. If we look at our next question, I'll erase all this here. Or the same part says use a formula. Our formula for a Pythagorean relationship is a squared plus b squared equals c squared, or the sum of the squares, area of the squares attached to the legs equals the area of the square of the hypotenuse. That's what those a's and b's stands for. So a squared, we can make that any of the legs. We'll make it 8 plus 16 squared equals x squared. 64 plus 256 equals x squared. And we end up with 320 equals x squared. Now at this point we know that we have to isolate for x, not for x squared. So we want to square root both sides. The square root of x squared is x, and the square root of 320 we learned was 17.9-ish. We put an approximately equal sign there. Okay, that's the work you needed to show for showing your formula for a Pythagorean relationship. Question 3, it says use a net and solve this surface area of a rectangular prism. So just like Monday's question, we know that this rectangular prism has 6 faces, and I'll just draw them here. And if we label this one, and I'll just use B for bottom, this will be T for top, this will be F for front, and this will be BA for back. This will be left, and this will be right. We have our net kind of set up so that we have all of the faces here. If I think about the bottom, and I'll just shade it in on my 3D prism here, and that's the bottom of the triangle. What are its dimensions? We can see clearly that it's 5 by 1. So since it's a rectangle, we're going to multiply 5 by 1. So 5 multiplied by 1. And if you wanted to actually, I should go back here. You could have actually put the formula of length times width in here, but since it's so small, I'm not going to. Oh, I just did. 5 times 1, which means the area of the bottom is 5. The area of the top, therefore, since we know that the top and the bottom are the same side, is also 5. If we look at the left and right, I'll just shade in the right here, it's blue. The dimensions of this, we see that this is 1 here, but we don't really see it here because it's not written. But if we look over here, the height of this is listed as 2.5. So therefore the right is going to be 1 times 2.5, which will be an area of 2.5 square centimeters. This will be 2.5 square centimeters as well. Not 25, but 2.5. And then finally, if we look at the front, and there's the front face of this particular prism, it is 5 by 2.5. So if I was to write it up here as a formula, length times width, it would be 5 is the length, 2.5 is the width, and 5 times 2.5 is 12.5. So this has an area of 12.5 centimeters squared, and this has an area of 12.5 centimeters squared. And then in order to calculate the surface area of the entire prism, all we have to do is add up 12.5 plus 12.5 plus 5 plus 5 plus 2.5 plus 2.5. This is 5, 10, 15, plus another 25 is 40 centimeters squared equals the surface area. Okay, so while I press pause, you can copy that down if you didn't have it. So that's the work that was expected. Question 4 gives us an integer question, and in this integer question we actually have a multiplication here. We have a brackets here where we have a subtraction in brackets. We have an addition, and we have a division. So we really have 4 things that we have to take care of. So the first thing, according to BEDMAS, B-E-D-M-A-S, is brackets. And some people think that, oh, let me grab a highlighter. Some people think this is brackets. But if you look inside there, there is no operation inside those brackets. And those brackets are there only to separate the integer sign of negative from the division sign. So those are not brackets. Those are just separation of operation sign from an integer sign. But these here, this right here, is a bracket. So we're going to solve that first. So it's 4 bracket, or 4 multiplied by 10 take away 13, which is negative 3. A lot of people might have put positive 3 there, but 10 take away more than you have is going to leave you with a negative number, plus 12 divided by negative 4. Now we have our second step. So we have brackets are done. There are no exponents in here. Our next step is division and multiplication in the order they appear from left to right. I am going to simplify all of my division and multiplication in one step. So I'm going to do my multiplication, which is 4 times negative 3, which is negative 12. And my 12 divided by negative 4, which is negative 3. And notice how I kept it in brackets to separate the addition sign from the negative sign. And finally, we have our last step, which is any addition and subtraction. And we have an addition. 12 negatives plus 3 more negatives are 15 negatives. So the expectation for your work is pretty well everything I wrote here. You might have only done the multiplication first and then the division, so you might have actually one more step, but that's okay. This is all you needed to show. Question 5 is your linear relations. It says graph the first 3 ordered pairs from the table. So our ordered pairs are 1 on the x and 7 on the y. So first thing I need to do is I need to label my axis. So I'm going to give this x-axis labels 1 through 9. And I'm going to give my y-axis 1 through 9 as well. 7, 8, 9. And my first pair right here is 1, 9, or 1, 7, excuse me. So I'm going to put a dot right there for 1, 7. Then 2, 6, which is right there. And 3, 5, which is right there. And then I'm going to connect it with a line. And I could actually go forever if I wanted to. And that would be the line. Okay? So that's the first thing. I graphed all 3. Then it says find the equation that matches all of the points on that line. Actually, maybe what I'll do is I'll just keep the line where it was there. Now the equation, we said the relationship between the x value and the y value, there is an equation that we can find for it. And we said that in order to find the coefficient of that relationship, or the slope of the line, we can actually find the difference in the y divided by the difference in the x. So the difference of the y divided by the difference of the x. The y column is going down 1 each time, so we're going to say the difference in that column is not 1, but rather negative 1. And the difference in the x column is 1. So the difference of y divided by the difference in x equals negative 1, which means this negative 1 is the coefficient of your equation. Okay? Now I'm going to leave the negative 1 coefficient there for a second, and then we'll come back and look at it later. So once we know that, our next job is to then say, is there a constant necessary? So what I'm going to do here now is I'm going to take any ordered pair, just like we used to. I'll take the first one, 1 and 7. And I'm going to substitute 1 for the x. And I'm going to substitute 7 for the y. So negative 1 coefficient, substitute 1 for the x, substitute 7 for the y. And then what I have here is I have an equation that's set up that says right here that both sides are equal, right? And if they are, we're good. We don't need a constant. But if they're not, we need to add a constant. So negative 1 times 1 is negative 1. And since negative 1 does not equal 7, in order for them to be equal, I have to add a constant of positive 8. Okay? Which means in the equation of all of the ordered pairs on that line, Negative 1 times x plus 8 is equal to y. Now, remember I said before that I'm going to talk about that negative 1. So negative 1x is the same thing as just a negative x. So in your equation, if you wanted to, what I would have written, I would have just wrote negative x instead of negative 1x. And that is your answer. Negative x plus 8 equals y for all values on that line, including the ones that we haven't drawn. If we extend that line forever to the left or forever to the right, we would find that any x-y value pair on that line would fit into the equation negative x plus 8 equals y. That's why it's linear. Our second last question is our algebra question from chapter 10. And it says use opposite operations to solve for x. So what we've learned so far in grade 8, which will be different than grade 9, but in grade 7 and 8 you learned that when you isolate the variable, the easiest way to use opposite operations is to get rid of the constant first, and then after you're done, get rid of the coefficient second, right? It's just an easier way to do it because we just apply basic integer operations of multiplication, division, addition, subtraction of integers. So if I'm going to get rid of the constant first, the first thing I'm going to do to both sides is subtract 1 to create a 0 pair with the constant. Then I'm left with x divided by negative 2 is equal to the sum of negative 5 and negative 1, which is negative 6. Once we have that, we are down to a one-step algebraic equation where it says x divided by negative 2 is equal to negative 6. Or if I wanted to, remember what we said, this expression is actually a negative half. So if we think of that expression as being this or this, they're both the same thing. But for purposes of opposite operation, what we're going to do here is we're just going to multiply both sides by negative 2. Okay? So what we end up doing by multiplying by a negative 2 is we isolate x by itself. We got x, and the product of negative 6 and negative 2 is a positive 12. And that's your solution for this question. And finally, your last question, question 7, comes from chapter 6 on fraction operations. Again, we have a bedmass question this time with a division of a whole number, which is a pretty tricky one, and the addition of a mixed fraction. So knowing the bedmass is something we have to follow no matter what kind of question we have, if there's more than one operation. We're going to do our division first. So I'm going to highlight this for you, and then I'm going to redraw it over here. So 2/3 divided by 4. Now we said before that whole numbers can be thought of as being over 1, and that's true because 4 and 4 over 1 are the same number. And the reason why we want to write whole numbers as over 1 is because we learned that to do division, you can do one of two things. You can find a common denominator and then make equivalent fractions and divide the numerators, or you can change division to multiplication and use the reciprocal, and multiplying two fractions together by the reciprocal of the second will always give you the same answer as division by the first fraction. So in doing so, we end up with 2 over 12, which you can keep as 2 over 12, or if you wanted, you could reduce to 1 over 6, because both of those fractions are the same thing. Alternatively, some smart people realize, hold on a second, Mr. McDonald, you said when we multiply fractions, we should always check if we can cross-reduce first. And you're right, I did say that. And if you look here, the 2 over 4, if you did cross-reduce it, would have became 1 over 2. And when you multiplied the numerators 1 by 1, you would have got 1. And when you multiplied the numerators 3, or denominators 3 and 2, you would have got 6. So you would have ended up with 3 over 6, or sorry, 1 over 6 anyway if you cross-reduced. So which one do we want to use, 2 over 12 or 1 over 6? Well, I'm going to use 1 over 6. Anytime I can keep my fractions smaller, it's easier for me to do because my multiplications become easier when I do equivalent fractions. Now that we have this down to just addition, we have a mixed fraction plus a regular fraction. Your options are you can add the whole numbers together and then add the fractions parts together and combine them. Or what I always like to do is just rewrite them as the sum of two fractions, either proper or improper, and I ignore mixed fractions altogether. So 1 2/5 and 7/5 are equivalent. Now that we have that, find our common denominator of 30. Create our equivalent fractions of 42/30 and 5/30. Now that you have the common denominator, add your numerators together and keep your denominator. You end up with 47/30 as your final answer. Now because that is an improper fraction, we were always told that reconfigure it as a mixed fraction if possible. How many 30s in 47? There's 1 with 17 left over. So your final answer is 1 and 17/30. Now here's the expectation. So you had your sheet to begin with, and you maybe got all the questions, maybe you didn't. But all of the questions you didn't get, I know it takes a lot of work, but just press pause and copy down the work. Think about what I said, and hopefully the next time you have questions like this, you can recall what mistakes you made in the past, and you could correct yourself and be able to handle any question I throw at you during these reachbacks. Stay safe.